Hi, my name's Mike, and today I'm going to make a Spring Reverb. I'm going to be using this thing called a Boom Tunes. It's a kind of like they call it a make anything into a speaker. This little driver just drives whatever you stick that onto. You can stick it on like a window or a board or whatever, cup. So I'm going to be using that, one of these little echo mics. So the idea is that there's a diaphragm in here that vibrates a spring and gives like a natural reverb type of sound. So I'm going to take that apart and then use that spring, attach it to the little driver here. So the sound will drive through the spring, and then that will be attached to this large piezo disc, which will be the pickup. That will feed into this PT2399. They call it a mic reverb board if you search for it on eBay, but it's a little delay unit. It comes with only one knob, which is a mix, but there's a couple modifications where we can add a delay length by removing this, one of the resistors and connecting to these points here. And then we can also, there's another mod I have to add a feedback control. So I will be rehousing all that stuff into this wood box that I got at Goodwill. It just had, I don't know what it was. I think it was silverware or something. It had some kind of like just cheap foam that I ripped out. All right, let's get to it. So I'm just going to take the little driver from the little Boom Tunes thing. That's the part that actually moves, the white part. And then the spring from the mic has these little plastic pieces. Take that little piece off and then glue it to the white piece. Okay, so I've got the little plastic piece glued on, still drying there. So the spring will hook onto that, stretch across, and then I think I'm going to try drilling two small holes, one on each side of the piezo disc, so the spring can hook into that hole, and on the other hole I'm going to try to suspend it with a rubber band stretched out to the other side of the box. It's basically trying to isolate the spring, piezo, and little driver, isolate them from vibrations from the box. And then also maybe the driver, I might try to use rubber bands to suspend it from the other corner too. So basically everything is in there. We'll have like a shock mount. That's the plan anyways. I was trying to figure out how I was going to suspend this little driver without it hitting the sides of the box and letting the spring bounce freely. So I was looking at the battery case, which I'm not going to use anymore. It's got a little hook right there. So I'm going to line that up on the center right there. There we go. So then I can hook a rubber band and it'll pull right from the center, and the spring will be pointing right opposite. That's the plan, hopefully. Okay, I got everything laid out how I want. We've got 2/4 inches up here, an input and an output, a double throw, double pull toggle switch for the power. The reason why it's double pull, double throw is half of it will be the 9-volt for the delay board, and then the other half will be the 3 volts that powers the driver that's going to be powering the Spring Reverb. And then down here will be the controls for the delay. So up here on the top there is a 50K, a linear 50K pot for the mix control, which is the same as which is already on the board here. And then over here will be the feedback control. That is an audio 100K pot. Here will be the length control. That is a linear 100K. And then I'm leaving the space open over here because I'm going to probably add an LFO section to control these controls. So I'm going to go ahead and drill those and start mounting everything. Okay, got my first controls and input, output, and power switch all drilled through and mounted. Still have to do the LFO section, but I'm going to do that after, get everything working. I cut some little 1/8 inch pieces of plywood to mount my circuit boards onto. So the delay board, this will just give me something I can put some screws into since this is too thin. And I'll just hot glue these onto that thin board. Okay, next I will be making the modifications to the delay board. There's a few things I need to do. In order to make the delay length modification work, we need to remove R27. It's right in here. So R27, it's a surface mount resistor, so best way is to heat it up and push it off to the side. And then we need to connect a wire to S and a wire to G, and we'll run that out to a pot that we can panel mount. And that will give us the length control. Next, I will be desoldering the original mix pot and running wires out to my panel for my mix control. For the feedback control, it will connect to the center of the mix, so I will jump off where I run the 3 wires to, and then it connects to the capacitor right here. The capacitor between the connection between the capacitor here and R21. It's hard to see, so right in there. So it looks like that's capacitor C15 and R21, so right between the two. And that will give feedback control. So I'll go ahead and start making those modifications. Here is the schematic of the LFO that I am building. It's based off of a 555 IC. I'm using this side of the circuit with an NPN transistor that is controlling the rate, the flash rate of an LED. This rate is set by this resistor. So I'm using a 20K potentiometer in place of this 20K resistor here. I am not using this section over here. So that looks like this on a breadboard. So currently I have a larger capacitor in there. The capacitor is this one right here on the schematic. So that is basically like almost, I guess you can almost kind of think of it as like the slope, or like how fast the peak rises and falls because the capacitor charges and discharges either slowly or faster depending on the size. So this one is a larger one, so it is a slower fade in and out. But if we switch that for a smaller capacitor, that rate is that charge and discharge rate is much faster, and it's more like a square, even though it still is a triangle, but it's closer to a square. So what I'm going to be doing, I'm going to be using a 8-position rotary switch with 8 different values of capacitors wired to that, so we can cycle through 8 different settings, and then also control the rate by this potentiometer. So I've got my 555 timer circuit here, and it is flashing this LED here as well as the panel mounted one there. So now I need to make my Vactrol. So what I'm going to be doing, I have a light dependent resistor attached to some wires. I'm going to be gluing, or maybe super glue just a little bit, right directly onto the LED, then cover that up with some heat shrink. The controls for this will be going up to the feedback and delay length. Both of these controls, the center lug is ground, so I will be running one of the legs to both. It'll just jump across to both. And the other lead from the light dependent resistor, my DIY Vactrol, will wire to the center of the control switch, or the toggle switch here, and then each of the outer lugs will wire to either other controls. So that will give you the ability to route the LFO to either knob. The switch has a center of off position with a on up and an on down. So that will be, and as you can see right now, it's controlling the power of the LED. So whichever way you switch it, it turns on the power. Power comes in on the center and then routes either side, jumps together and back out to the LFO power, or the 555 timer circuit power. Okay, here it is, my completed DIY Spring Reverb. In most of my builds I try to label all the controls, but in this one I went with symbols. I just went with the normal power symbol for the power. For the mix we have an X. The feedback is a loop with an arrow feeding back, and then the length is almost like an L with an arrow, so like the amount of length. And then over here in the LFO section, we have the power routes to either of the feedback or the length, those two symbols. And then, if we turn it on, each one of these knobs affect either the fading in and out and the speed. So both of those draw to the LED, which then draws to the toggle switch. And then up here we have an arrow in for the input and an arrow out for the output. And that's pretty much it. Hope you enjoyed watching this video. I've really enjoyed making this, something I've been trying to make for a while. And if you liked it, please give a like and subscribe. Thanks for watching.